Next, we want to take a quick look at how STL files are created for 3D printing. When you save an STL file, a tessellation process happens. The two-dimensional outer surface of the 3D model is created using small, tiny triangles called facets, and this information is stored about the facets in a file. If you have a simple 3D cube as shown below, it can be covered by 12 triangles. Since the cube has 6 faces, it adds up to 12 triangles. If you have a 3D model of a sphere, it can be covered with many small triangles as shown in the image. The more triangles, the greater the file size. The Albert Consulting Group of 3D Systems realized that if they could store the information about these tiny triangles in a file, then this file could completely describe the surface of an arbitrary 3D model, which formed the basic idea behind the STL file format. The STL file format provides two different ways of storing information about the triangular facets. These are called the ASCII encoding and the binary encoding. In both formats, the following information of each triangle is stored: the coordinates of the vertices and the component unit normal vector to the triangle. The normal vector should point outwards with respect to the 3D model. When creating STL files, there are special rules that must be followed. The vertex rule states that each triangle must share 2 vertices with its neighboring triangle. The orientation rule states that the orientation of the facet must be specified in 2 ways. All positive octant rule states that the coordinates of the triangle vertices must all be positive. The triangle sorting rule recommends that the triangles appear in ascending z-value order. The next steps in creating the file for 3D printing is to use a slicing software which slices the STL file and creates G-code files. The slicer cuts up the STL file into numerous flat horizontal layers based on the settings and calculates how much material your printer will need to extrude and how long it will take to do. All of this information is then packaged into a G-code file which is sent to the printer. The printer follows the G-code file and lays down two-dimensional layers upon layer until the 3D object has been created. When slicing your part, most CAD software will let you choose a parameter called the chord height or tolerance. The chord height is the maximum distance from the surface of the original design and the STL mesh. Choosing the right tolerance is important to make your prints look smooth and not pixelated. Recommended tolerance is typically between 10 and 1 micron. And this tolerance will typically result in good quality prints. Reducing the tolerance lower is pointless as the 3D printers cannot print at that level of detail. The angular tolerance limits the angle between the normals of the adjacent triangles. By default, it's set to 15 degrees. Decreasing this tolerance will improve the print resolution.